Hello, this is Keith All, and welcome back. Today's tutorial is going to be on how we could analyze a data set and add additional columns or helper columns to our data set by using the NumPy where function within Python. And as you can see, I'm going to be using Python in Excel to do this. So let's first go up to data, and I'll show you here in a second. Actually, formulas, and then the edit initialization. I'm going to show you that with Python and Excel, it comes preloaded where it automatically imports these certain libraries over here on the right hand side. And we're going to be using pandas and of course NumPy. And the alias for that is MP, and the alias for pandas is PD. That's the traditional alias that you use. But the first step is what we're going to be doing. If you look at this data set, it's like a mock-up data set of an HR department. And we want to be able to analyze the data a little bit further. And in some cases, when you're analyzing data, you may need to create additional columns to analyze your data a little bit further. So that's what we're going to be doing here. Our first step in Python is we're going to create a data frame. And a data frame is just like a data set in Excel. And what we want to do is we want to create that data frame and point it to our data set, which is over here on the left. And we do that by initially in Python and Excel, you have to type in equal sign and then py and then tab into your cell like this, equal py, and that gets you into Python mode within Excel. And then once you're in that, then you can start typing in your Python code. I'm going to just press escape here. But basically what I did was I created a variable called df, stands for data frame, and then I highlighted our range here in our data set, as you can see. And we're using the parameter headers equal true. So in other words, when I select this entire data range, including the headers, it signifies to Python, okay, our top row is the header. So our next step is we want to create some helper columns. And as you can see, I already pre-written the code, so I'm going to show you, explain to you the code itself and in each and every cell. And remember too that this data set, this spreadsheet is going to be downloadable for you in the description. So in this data set, we want to look over here and we want to be able to analyze this data further by calculating what the yearly salary is for any particular individual. And right now our data set only has monthly salary. So what we could do is we could take the monthly salary as we see here. So I'm creating a new column or a helper column in our data frame. I'm calling it annual salary, and that's where DF is comes in, and then you put in square brackets the name of the new uh, column, and then you're going to set that equal to, we're going to access the monthly salary column that already exists, and we're going to multiply it by 12. And then what this does, it goes through every single row in our data frame and takes the monthly salary multiplied by 12, and then it gets stored into this additional column. And if you look at the annual salary down here on the left, and I'll explain this in a second, but it calculated that out for us. Now, our next job is, well, we want to segment employees for additional salary distribution insights. So what we're doing is we're taking the salary tier column over here Let's find it, salary tier. Oh, no, that's the new column that we're going to be calling. And we're taking the monthly salary and we're determining whether or not it's going to be low, medium, or high. And we do that by, again, we give it a threshold, okay? So what this is doing here is we're taking we're assigning the values of the np.where into a new column name called salary tier, okay? And as you can see over here, that's what we're doing. So let's look at this further. The np.where, the first parameter to it is going to be our condition. Our condition in this case, we're going to look at the value of monthly salary, and then we're going to determine, is it less than 5,000? If it is, we're going to assign this particular row the value of low. So as you can see, we have some low values here, okay? That's a monthly salary, not yearly, okay? If this happens to be false, then it goes to the next parameter, and it does, in this case, we're doing another where clause. It's like an if statement in Excel. We're going to, again, look at the monthly salary column and determine if it's less than 9,000. Because the first condition says, okay, it's not less than 5,000, must be greater than 5,000. So now it's, we're determining whether or not it's 5,000 or a greater than 5,000 but less than 9,000. If that is true, we're going to assign the value to medium. And if that winds up being false, then we're going to assign it to be high. And that's the how we create this particular column here. So now let's go on to the next one. We want to determine age groups. So if we go back to our data, we look at the age column, and we want to be able to group these ages in certain buckets, let's say. Okay, and we want to, as you can see, I created it here, and we assigned the value to young, mid-range, or even senior. So again, it's like this is like the last one, but we have different conditions. So we create a new column called age group, and we set that equal to np.where. First condition, first parameter is a condition. What are we trying to check? We're trying to check the age column if it's less than 30. If it is, we assign the value of young for that particular row, and then it goes on to the next row and does the same condition test. Okay, if it isn't less than 30, then we do another np.where, and we ask whether or not the age column is less than 45. If it is, we assign the value to mid-range. If it isn't, then we assign it to senior. Okay, so that means that if it's senior, that means it must be equal to or greater than 45. Okay, our next helper column that we want to look further into is it may be useful for analyzing retention patterns. So we look at the, we create a new column called tenures category, which is right here. And we look at the years at company column in our existing data frame. So we look at this column right here, years at company. So we come over here and we do another np where. It's like the last one, but we're doing different type of conditions. So now we look at the years at company column. If it's less than 3, it must be a new hire. Okay, if that is not true, then it jumps to the third parameter, which would be the false condition. Okay, and we do another np.where, and we determine if the years at company is less than 10. If it is, we're going to assign the value to be experienced, and if it isn't, then we're going to assign veteran over here in this column. Okay, now let's do another one where we're doing actually math calculations. And basically, this creates a composite measure of performance, effort, and attendance. So what we're doing here is we're creating a new column called productivity index, which you'll see over here on the right. And we're taking a performance score column. Let's go back to our data. Our performance score is right here, okay? Now we're going to take that value, multiply by 20, and add in any overtime hours. So let's go back to our data. Overtime hours is right here, okay? Okay, so we make that calculation, and whatever that calculation is, we're going to subtract from that the number of sick days taken, okay? Which is, let's go back here. Number of sick days taken, okay? And then once it does that, we're going to divide that calculation by 10. And then we're going to, after all this is done, and then we're going to round it to do 2 decimal places. That's what round 2 means. So if you come over here, that's what it's doing over here. It rounds it, okay? I'm just formatting this in Excel. Let's go over here and you'll see. Let's increase the decimal point, okay? And that's why it shows just a single decimal point. But anyways, let's go back over here. So that's how this is done, okay? Our last example is we want to determine promotion eligibility. So we want to identify employees that are likely due for a promotion. And this is how we're calculating it up here. So we create a new column, promotion eligibility, over here. And then we're going to assign that to np.where. Okay, again, this is going to be, look at this condition here. We're going to do an and type of condition here, and that's what this ampersand here means. We're going to first look at this condition. We need to determine whether or not the performance score is greater than or equal to 4. If that is true, then it's going to look at this condition here. And then we're going to look at the years at company value and determine if that's greater than 3, okay? If both of these conditions are true, then we're going to assign the value as eligible. If either one of these are false or both of them are false, then it's going to jump over to this false condition over here and assign the value to not eligible. So that's how this np.where falls into play. So our last here is, once we create all these new columns here, we want to be able to display the values or these columns. And one way to do that is create a new a data frame, not a data frame, but a new variable, and we're going to assign it to, we want to display only these columns in our data frame. Okay, so that's what we're doing here. We're taking all these additional columns that we just created up here, and we're going to pass it in as a list. That's what these square brackets are for. And we're going to comma separate them, okay? And then we assign it to this variable here. And then we do our data frame and ask it to pass in this list of columns and display it. So that's why you're seeing this right here. It's only displaying the columns that we want to show. And that's how we got to this end result here. So again, if you're adding additional columns, that means that you want to try to further analyze it, and then you'll probably want to create some charts and graphs with these new columns. So hopefully this gave you an idea how you could take a data set in Excel, basically create a data frame using Python, and then how you could create additional columns or helper columns so you could further analyze the data to create your graphs or charts. Again, I want to thank you for stopping by today. Make sure you subscribe to my channel, and as always, please like and share this video, because this helps with the YouTube algorithm to get this video out to more people in this space that want to learn more about this. And again, this data set or this Excel spreadsheet will be in the link in the description for you to download and follow along. Thanks again. You have a great day, and I'll catch you on the next video.